Mid-side encoding is the process of taking a conventional two-channel stereo audio signal with a left channel and a right channel and converting that into a different type of two-channel signal, the mid channel and a sides channel. To perform mid-side encoding, what we're going to do is take the sum and difference of our stereo audio signal. Consider if we had a signal that was panned to the center of our mix. In this case, that signal is going to have identical amplitude in the left channel and the right channel. Therefore, if we were to take the difference or subtract one channel from the other one, what's going to happen is anything that's panned to the center will cancel out. However, things that are panned uniquely to the left side or the right side will not cancel out with anything. So what will be left over with is something that we can call our sides channel. Now consider what would happen if we were to sum together our left and the right channel. Anything that's panned to the center will actually increase in amplitude and be louder. Things that are panned to the left and the right will not increase as much in amplitude. After we perform mid-side encoding, then we can process the mid and sides channels independently. So let's take a look at how we can write our own computer code to perform mid-side encoding. Here in Matlab, I've started a script called MS Processing. We'll use it in this video to perform mid-side encoding. And then in a later video, we'll look at mid-side decoding. To begin with, let's import in a stereo audio file. I have one saved in my current folder called Stereo Drums. So we'll use the audio read function and then the name of the file. We'll assign the result of this function to two variables. First will be a variable that we'll just call signal for now, and then we'll also get out the sampling rate. If we'd like, we can listen back to the stereo signal. So we have a conventional stereo mix for drums, where certain instruments or elements are panned to different locations across the stereo field. Our first step in performing mid-side encoding is to first separate the left and right channels. So right now we have a two-channel stereo signal. We have to first get out the individual mono channels, one for the left and one for the right. Our left channel will be created by indexing our signal, where we'll want to get out all the samples that are in the first column. So here we'll use :1. Then for our right channel, we're going to index our signal, get out all the samples that are in the second column. Now, if we like, we can listen back to just the left or just the right. Our next step then is to perform mid-side encoding. Here, we're going to create two signals. One will be called the sides, and the other one will be called the mid. So we'll start out, we'll create the sides. This is going to be 1/2 multiplied by our left channel minus our right channel. Then we'll also get out the mid, which is going to be 1/2 multiplied by the left plus the right. So another way to think about the sides is that it's the difference signal. Way to think about the mids is that it's the sum of them. So now, instead of listening to the left or the right, let's listen back to just the sides or just the mid. Now we'll change this over to mid. Now we have everything separated out. So if we like, we could have a section in our code here to perform some type of processing where we're going to change either the mid or the sides independent of the other one. And then we're going to have another section where we're going to perform mid-side decoding, where the result will be to have a new left and the right channel that we can combine together into a stereo signal. So that completes what we need to accomplish for mid-side encoding.